The complexity of multi-engine airplanes makes it imperative that you use the proper checklist for all ground and flight operations. When you're ready to start the engines, clear the area around both propellers as well as around the entire airplane. Some aircraft specify which engine is to be started first, while in others there is no difference. With two engines, you have several options to help maintain directional control while taxiing. In most cases, nose wheel steering is sufficient for normal operations. But if you need to make a tighter turn, you can use differential power. This is accomplished by increased thrust on the outside engine. In a strong crosswind, an airplane tends to weather vane into the wind. Differential power can help you maintain directional control by applying more power to the upwind engine to counteract the weather vaning tendency. Differential braking should be your last option for directional control, since it can increase wear and possibly overheat the brakes. Your pre-takeoff check in a multi-engine airplane is similar to that for a complex single-engine aircraft. But with two engines, there are some special considerations. When power is increased for the engine systems check, both engines are run up together. The actual check of the systems, however, is done on each engine separately. The propeller feathering check is another unique consideration for multi-engine airplanes. In flight, this system lets you move a propeller to a streamlined position to reduce drag in case of an engine failure. The ground check involves moving the propeller control into the feather position, watching for an RPM decrease, and then moving the control back to the normal setting. It's very important not to let the RPM go below the limit specified in the pilot's operating handbook. Once the pre-takeoff checks are done, review your pre-flight planning factors before taking the runway. This review includes the procedures and airspeeds to follow in case of engine failure. Two of these airspeeds are the best single-engine angle of climb, or VXSE, and the best single-engine rate of climb airspeed, or VYSE. This speed is represented on the airspeed indicator by a blue radial line. Specific engine-out procedures are covered later in this presentation. For a normal takeoff, you should set the flaps according to the manufacturer's recommendations.
Front range traffic, Crusader 90832 Charlie, departing runway 26 at front range.
Apply power evenly to both engines and watch for any directional control problem which may indicate uneven engine acceleration. Once you have full power, check all the engine gauges to make sure both engines are operating properly. Accelerate to the recommended liftoff speed, or VMC, plus 5 knots, whichever is greater. In any case, never allow the airplane to become airborne below VMC. After liftoff, accelerate to the best rate of climb airspeed, or VY, and maintain that speed for the initial part of the climb. Retract the landing gear when you have a positive rate of climb and can no longer land on the remaining runway. If flaps are used, bring them up in accordance with the pilot's operating handbook. Once you've reached a safe maneuvering altitude, reduce power to the desired climb setting. Turn off the electrical fuel pumps one at a time while monitoring the respective engine instruments. Let's briefly look at a crosswind takeoff. The procedures are essentially the same as for a single-engine aircraft. You'll use the ailerons to prevent drift and the rudder to maintain directional control. As soon as you lift off, establish a drift correction to stay on the runway centerline. If a maximum performance takeoff is required, set the flaps as recommended by the manufacturer and follow the procedures in the pilot's operating handbook. Make sure you use all of the available runway. Apply full power before releasing the brakes. Accelerate to the recommended liftoff speed, or VMC, plus 5 knots, whichever is greater. Rotate firmly and accelerate to the best angle of climb speed, Vx. Retract the gear when you have a positive rate of climb and can no longer land on the remaining runway. Once you have cleared the obstacle and reached a safe maneuvering altitude, establish the pitch and power setting for a best rate of climb airspeed, Vy. After you've set the power, synchronize the propellers. If they aren't rotating at exactly the same RPM, you will hear a pulsating sound that can be both annoying and fatiguing. To synchronize the props, match the indications on the tachometer as closely as possible, then slowly adjust one of the propeller controls until the pulsating stops. During the climb to your en route altitude, you may want to transition to a cruise climb. The higher airspeed reduces the time en route, improves engine cooling, and offers better forward visibility. The lower climb rate is more comfortable for passengers, especially in a non-pressurized airplane. Because of the increased speed and altitude range of a twin, you must plan ahead for the descent to your destination. A cruise power descent with its higher power setting keeps the engines from cooling down too rapidly. It also offers improved passenger comfort and ground speeds. During your descent, perform the appropriate checklist items and review the traffic pattern procedures. A common technique for a normal landing in a multi-engine airplane is to use a stabilized power approach, where the power is adjusted to a specific setting just before pattern entry. The drag created by gear and flap extension slows the airplane to pattern airspeed and helps keep power adjustments to a minimum throughout the pattern. You may also need to adjust your airspeed for compatibility with other traffic, but don't reduce it below VYSE. In no case should you allow the airspeed to go below VMC. As you approach the runway, make a smooth transition to the flare and slowly retard the throttles to idle. Remember that a rapid reduction in induced airflow will cause an immediate loss of lift. During the first part of the landing roll, use rudder and nose wheel steering for directional control. If runway and traffic conditions permit, avoid using the brakes until the airplane slows down. For a crosswind landing, whether you use crab or the wing-low method on final, make sure the airplane is aligned with the runway before touchdown. If you have to go around from a rejected landing, immediately apply full power and establish the pitch attitude for either VY or the manufacturer's recommended airspeed. Reduce drag as soon as possible by bringing the flaps up to the recommended setting and raising the gear as soon as you have a positive rate of climb. You have interrupted the normal landing process, so it's very important to make sure you go through the complete before landing checklist again.